Thank you for joining this lesson. We're going to discuss the solution of simultaneous equations. And in this video, we're going to focus on the graphical method of solving simultaneous equations. We are told using the grid provided below, solve the simultaneous equations. Then we have 3x minus 4y equals to 10. And the other equation is 5x plus 7y equals to 3. So the first thing we do is to make sure that our equations are in the form y equals to mx plus c, so that it becomes very easy for us to substitute and find a table of values. Going to the first equation, we can have 4y at one side. This will be equal to 3x minus 10. 4y equals to 3x minus 10. Now we can divide through by 4, so that we have y equals to 3 over 4 x minus 10 out of 4, whereby it can simplify to 5 out of 2. Yes, so that is the equation. Now if we start coming up with a table of values, then we need x, we need y, such that some values of x, if we start at 0, for example, then we will substitute 0 in this equation. Wherever we have x, we substitute with 0, and we will find that y will be equal to, because this part becomes 0, 5 out of 2, which is negative 2.5. Negative 2.5. Next, we can go to a value like 3. Let me go to 2. So when we have a value like 2, we substitute 2 here, so that the equation becomes 3 quarters into 2 minus 5 over 2. And when 2 divides by 4, we get 3 out of 2 minus 5 out of 2. That will give us negative 2 out of 2, which becomes negative 1. We are doing the normal substitution. We can add a third value, for example, at 4. When we substitute, you discover that when we substitute 4 here, the equation will become the value of y equals to 3 out of 4 into 4 minus 5 out of 2. So this is going to be 3 minus 2.5, and this will give us 0.5. So these are 3 values or 3 coordinates for the first equation. So we can settle the table there, and we go for the next equation. This equation is talking of 5x plus 7y equals to 3, in which we can say 7y is equal to negative 5x plus 3, so that the value of y now becomes negative 5x plus 3. None of them is divisible by 7, so we can just have over 7 like that. So that is the equation. We can have the values of y and those of x, so that we come up with a table. And when we do coordinates, like let's say at a coordinate like negative 2, 5 at negative 2, when we substitute here, we're going to have the value of y becoming negative 5 into negative 2 plus 3 out of 7. So this is going to be, we have negative 5 and negative 2 becoming positive 10. Now positive 10 plus 3 becomes 13 over 7. So 13 divided by 7 becomes 1.9. So we will have 1.9. We can go to another value like, if we talk of something like the value of x being a negative, that was negative 2. So now we can talk about positive 2 when it is at 2. what will be the value of y? So the value of y again is going to be negative 5 into 2 plus 3 out of 7. This is going to give us, we are having a negative 10 plus 3, that becomes negative 7 over 7, which is negative 1. Therefore, we're going to have negative 1, the coordinates there. Then we can have a value like 4 positive, so that we say the value of y is equal to negative 5 into 4 plus 3 over 7. So we'll have negative 20 plus 3. Then now we divide this by 7, we get negative 2.4. Negative 2.4. Negative 2.4. Yes. So the graph has already been plotted here. We already have the axes labeled, y and x. So ours is to plot the lines. Let me begin with the first line, which is here. 0, negative 2.5. So 0, negative 2.5 is going to be a coordinate at this point. Coordinate at that point. Then there is a 2, negative 1. 2, negative 1. The coordinate is at that point. Then 4 and 0.5. So 4, 0.5 is here. That is going to be the first line. We can plot it first. So when I place my ruler there, I'll be able to draw the line, and you can allow me to change the ink that I'm going to use. I can use a different ink, like me use red. Yeah. Yes. That is the first line. Now we can draw the second line, whereby we're going to use the coordinates the other side, negative 2 and 1.9. So negative 2 and 1.9 is going to be a coordinate at this point. That is the first coordinate. The second coordinate is going to be 2 and negative 1. So 2 and negative 1 is going to be a coordinate at this point. And finally, 4 and negative 2.4. So 4 and negative 2, when you go to 0.4, should have the coordinate at this point. So those are the three coordinates for the second line. So we can do our graph now, whereby I'll use a different color from the coordinates. Then I pick my ruler. So I'm going to have, yes, that is where I'm going to have the line. So we have the two lines here. Now with our two lines and a point of intersection, we are going to pick the coordinates of the point of intersection. That is going to be our simultaneous solution. So the point of intersection is coordinate 2, negative 1. Coordinate 2, negative 1. This means now the value of x is going to be 2 in the simultaneous solution of the two equations, and the value of y is going to be positive 1. So that is how we solve a pair of simultaneous equations graphically.